One of the most frustrating things about being an adult or adulting is that you're constantly having to be interacting with customer service somewhere, whether it's Amazon or your local power company. You're always needing, it seems, to have some issue resolved. Well, it seems that more and more, instead of talking to people, we're interacting with these little chat bots. So you go to a website and it says, "How can I help you?" And you start chatting thinking it's a person, but it's actually a bot. In fact, they even say things like "you're welcome" and "thank you." So what are these chat bots? Well, believe it or not, it's part of artificial intelligence and this growing trend that companies are using to interact with the public. So what is artificial intelligence? How is it different from organic or natural intelligence? That's what we're going to look at in this video. Let's get started. So I want to introduce the idea of artificial intelligence to you. I do want to preface by saying this is a very introductory video to expose you to some of the ideas about artificial intelligence. I am not a computer scientist, so I'm just going to give you some of the basic ideas that go into artificial intelligence and some of the really cool things that we're doing with artificial intelligence. So let's start by talking about natural versus artificial intelligence. So natural intelligence, especially when you think about human natural intelligence, right, is this organic, carbon-based intelligence that resides in our brain, and it allows us to adapt to new surroundings by combining several cognitive processes. So lots of neurons firing, memory, we got the hippocampus, the amygdala, we got all these outer parts of the brain, the cerebral cortex involved in this this natural intelligence. Well, artificial intelligence is not using this organic material. Instead, it's using a digital machine that tries to replicate human behavior and do human-like tasks. So let me remind you, when we think digital, we're thinking of zeros and ones, like a binary flow, a system that is on, off, 0, 1. So artificial intelligence, right, is different. It's using machines instead of organic material. So what are some AI, artificial intelligence, applications that you're commonly probably seeing, right? Web search engines, Google. So if you think about it, when you go to Google or whatever you use and you type in something and you want it to bring back some results, the web engine actually has to be pretty smart, right? It would be easy just to match the words you type to the millions of results, but it needs to be smart enough to predict what you're likely asking for, right? So if I type in strawberry milkshake, there could be millions of references to that on a web, maybe in somebody's short story they wrote, maybe at my local cookout on the menu, maybe a recipe, how to make it. So AI is helping us with our search engines to help us determine what is applicable. Also, one of the most interesting things to develop are recommendation services. Do you ever wonder why Netflix seems to recommend things that you actually probably want, right? I'm always amazed when it says, you liked this, you might like this. And I say, well, yes, I would. I should watch that. YouTube, TikTok, especially that algorithm seems to be really good at predicting what you would like as well. These are using artificial intelligence to gather data and then give you what it thinks you would want. One of the most fascinating is this new speech recognition program. Siri, of course, Alexa. These new speech recognition, the ability of a computer to recognize all our different dialects and patterns and words and languages and actually answer in a coherent way. That is using a lot of artificial intelligence. The Tesla craze with the self-driving cars and how that's using artificial intelligence. They're saying now that these self-driving cars may be safer than actual human driving cars, or at least that's where we're going in the direction. And then some older applications, if you think of strategic games, the Deep Blue chess game, which beat Garry Kasparov, the famous chess player, right? AI has made significant improvements in my lifetime and probably yours as well. One of the most interesting to me that I actually just heard a podcast on this is there is a company in Ukraine called Respeecher, and they're using AI to replicate voices. Prime example, if you are a fan of the Star Wars series, you probably are familiar with Darth Vader and the Darth Vader voice played by the famous actor James Earl Jones. Well, James Earl Jones has retired, but he signed off the rights of his voice to Disney, to the Star Wars franchise, so that they can use his voice in the future. Well, how does that happen if he's no longer voicing these characters? Well, this program actually uses AI with a lot of recordings of his voice and then is able to replicate, right? This recent Star Wars, the Obi-Wan series that came out, that actually was all AI digitally generated his voice. All right, so lots of really cool AI applications that we're seeing in our world today. So let's talk about the types. The first, which is the most basic AI, is reactive AI. And this is basically using simple classification and pattern recognitions, but it doesn't have any memory. So if an AI doesn't have memory, it can't learn and use past information to inform the future. An example of this is the Deep Blue Chess program that I told you that defeated the chess champion Garry Kasparov. So this is our most simple form of AI. It's just all about classification and pattern recognition. We move up a little to AI that has some limited memory, and that's things like our self-driving cars. So they can use data and memory to actually now make predictions about what's going to happen. Oh, this car is likely to come over based on previous things. The problem with this is that it's still vulnerable to outliers, because there's all these outliers which the program probably can't predict. The program might not be able to predict that there's going to be a trolley that's lost control and is barreling down San Francisco's street. So limited memory is really where we are. This is our current state of AI. Now, a lot of people are projecting that the next type of AI that we're going to really see is the theory of mind AI. This is a step up, because what it can do is it can understand human motive and reasoning, right? Right now, it's just based on decisions, on facts, on data. But this AI would incorporate humans' unique mind and can learn from our motives. So this can learn with fewer examples because it understands the intent of humans, our emotions, our motives, okay? Some people say we're close to this. Some computer scientists say we're a long way away from it. Then the ultimate type of AI would be sort of general intelligence, self-awareness, where it's an AI that is self-aware. It thinks it's its own being, right? It has a sense of self, so it has a consciousness. This, of course, does not yet exist, and it's really one of the many people consider to be the biggest goals that a lot of scientists work towards. All right, so those are the types of AI. I want to talk about a few interesting AI projects. And these are ones that I picked that really relate to science and biology in particular. I think they're fascinating. The first one is DeepMind. This is a Google project. And if you've taken any biology class, you might remember about proteins. Proteins are basically these long chains of amino acids that fold, right? So they have four structures. They have a primary structure, which is just the amino acid sequence. Then they start to fold into these things. That's the secondary structure. And they fold based on the interactions of these amino acids. So this amino acid here might be attracted to that amino acid there. They have these interactions and they start to fold. Then the tertiary structure is when we start to include other outside factors, so it folds again. And then finally, these proteins fold into what we call the quaternary structure. Now, this has long been a problem in science, because you can imagine the power, the mental power to consider, how this molecule interacts with this one, and that means it'll fold this way and this way, has been a challenge. So recently, Google's DeepMind was able to predict the structure of all proteins in just 18 months, all proteins that we know of. That is crazy. So this is opening up wide areas of research now in science and in protein study, because we now can actually see what the shape is, because the shape matters, right? Misfolded or misshapen proteins interact differently. So that's a really cool AI project that's really advancing science. Another one that I'm a little more scared about, and I'll tell you why, is one called Deep Vision. And basically, what it's looking for is this is a program funded by the USAID, and it's going around the world looking for potential harmful viruses, right? We've been through this pandemic with COVID. No one saw it coming, we say. So this program is actually going out looking for viruses that might be harmful to humans, publishing those sequences so scientists can develop vaccines. Well, in theory, that sounds great, right? Oh, well, let's figure out what the viruses are, and then we can make all these vaccines, and we'll have them stockpiled in case there's a problem. Well, here's the issue. Virology, the science of virology has come so far that if we're publishing these harmful viruses to the internet so that anyone can find them, there might be some foul players, some nations, maybe some, I don't know, a lone scientist who then uses our system of transportation to unleash this harmful virus, which this program discovered. So I'm a little leery about this. I know there are smart people working on both sides of this, but that is an AI project which has a potential to do some good, but also has a potential to go pretty bad. All right, so I mentioned artificial general intelligence. This is what I mentioned, the ability of an AI, an artificial intelligence machine to solve an arbitrary problem. Now, it would be able to understand or learn any intellectual task that a human being can do, and would maybe even have some sort of consciousness. This is the primary goal of many AI researchers. I personally think we're a long way from this. Some people are a little more optimistic. Then the question might become, well, how would we know if we have achieved artificial general intelligence? How would we know if a computer, a machine, actually achieved this? Well, there's two sort of common tests, or one really common one and then another one I threw in there. One of them is called the Turing test. Alan Turing, you may have watched the movie. He helped crack the code of the Nazis. And his test said that, and this is the diagram, to know if something was actually able to have artificial general intelligence, you'd have to have one person, C, interacting with both A and B. A would be the computer, the machine. B would be another human. And if this person said, oh, I think this is the real person I'm interacting with, then they have passed the Turing test, though they have achieved general intelligence. Steve Wozniak, one of the co-founders of Apple, he says this would be accomplished with a coffee test. He said, there's got to be a robot or a machine that could come into a room and figure out how to make a cup of coffee on its own, right? So it's got to find the coffee machine, fill it with water, plug it in, find the beans, get the filter, like all the things that go along with coffee. If a machine can figure out how to do that on its own, then it has achieved general intelligence, official general intelligence, right? I think we're a long way from that personally. All right, so what is machine learning? Basically, machine learning, and you'll hear this word a lot, is when a machine basically understands and learns things. And I've used this little diagram here to sort of show you where I think these fall. Machine learning, to me, falls under the umbrella of artificial intelligence. But if you go deeper than machine learning, that's deep learning. That's some of the more advanced AI that we've been talking about. So what is learning? Learning, then, is the ability to leverage data and improve performance. When humans learn, that's what all we're doing, right? We've gotten some data, and now we've learned that data, and we can improve our performance on a series of tasks. So how does this happen? Well, machines use algorithms, I'll go over this a bit more in a moment, and sample data, which we call training data, to make predictions. So it takes the data, we come up with some algorithms, and then make predictions of other data. So Let me give you a little flow chart of how this works. So the first thing we got to do, if we're going to make an artificial intelligence, let's say we were tasked with that, what we do is we need large amounts of training data. So we just have to have a ton of data about what we're studying. If we're studying protein folding, we'd put that in there. If we're studying virology, we'd put all that in there. So we got to put a ton of data into the machine. Then what we have to do is the machine analyzes the data and looks for correlation and patterns, right? So it's noticing, oh, there's a pattern with this data. Oh, there's a correlation with this data. So it's looking for these patterns, looking for these correlations. Once it finds them, it can then make predictions based on the pattern of what a future state may be, right? Now that's obviously very simplistic. So let me go over how this might really work using an algorithm. So how do these machines learn? What's their process? So first of all, they use many different programming languages. Python and Java are two big ones that are used. And programming that AI includes acquiring the data, as I mentioned, and creating these algorithms. Well, what are algorithms? So you've probably heard I mentioned like TikTok has a famous algorithm that they can predict what you want to watch. Well, an algorithm at its base is really just a rule that provides a computer with step-by-step instructions on how to complete a task. So it's really just some instructions, a list of instructions that a computer needs to do. So let me give you an example of a very simple one. This is Euclid's algorithm for determining a greatest common divisor of two numbers, right? So if we were making an algorithm, we'd have to input something here, A or B, and then we do some checks. Is B equal to 0? If yes, that's it. If no, then we go to the next option. Is A greater than B? If no, we go to this and then go to this, right? If we get no's, and then we continue going back. So it creates these loops. And this is basically what an algorithm is. It goes from step to step to step to step of these rules and then makes a prediction based on these rules and predicts based on the patterns that we saw. Okay, so is there risk? Well, many philosophers argue that giving machines rational thought or conscious capacities is an existential risk, a risk to our existence, because their programming may not be good for humanity. So many philosophers argue that deep in the programming of these machines, there has to be a rule. The algorithms all have to include beneficial goals to humanity needs to be included in all these deep learning machines. So to create responsible AI, I really think you need to do a few things. One, AI has to be unbiased, right? We know there are lots of examples of AI being used around the world, which may have been programmed using only Caucasian, only white people. And it is biased towards them and maybe makes mistakes when you're looking at people of color, right? So we need to make sure that our AI is unbiased and it doesn't lean towards one direction, that it actually is an unbiased AI. We also need to make sure it's secure. AI should not be able to be tampered with and infected by viruses, especially if we're using it for very essential things. I mean, we also then at the same time need to be able to monitor it and make sure that this AI doesn't get out of control, my opinion. And then I think one of the most important is that it's got to be human-centered. We've got to train AIs, machines, to be human-centered, to take human life valuably. So I want to end on a philosophical take. I like to do this on occasion. I like to learn from science and maybe take a little philosophical note from science. So what can we learn from teaching machines to learn? So I just explained a lot about how we can teach machines to learn and do things to us. Well, how can we make decisions for ourselves? Remember how it works. When you learn something, computers then do some reasoning, they collect data, and then they self-correct, right? So from all the data, they do the reasoning, then they self-correct and get better next time. So as machine learns and get better, there's a lot of self-correction. So I like to take this a step further and say, maybe as humans, if we took on some of this programming as philosophy for our life, it might help us. When we learn and use our reasoning, and then if we find we're making mistakes, if we correct those, go back, do some more learning, reasoning, I think we grow as humans, right? So many of us are afraid to correct ourselves, but really, that's what learning is, making corrections and moving forward.